again, welcome back. We are continuing now on our A-level physics topics. In a fairly short video this time, we're going to be looking at stable and unstable nuclei and also reminding ourselves of the three types of radiation. We'll be introducing the strong nuclear force and also briefly revisiting radioactive decay. Last time we looked at the inside of the atom and you'll recall we discussed the nucleus. Now if you stop to think about it, the nucleus is something of an issue, an enigma. If you consider that it's actually packed with positively charged protons and neutral neutrons all pushing away from each other through the electrostatic repulsion, well, surely then the nucleus should simply disintegrate. But it doesn't, obviously. Atoms exist and most are quite stable. There must therefore exist a force holding them together. Thus we have the strong nuclear force. This force must be strong enough to overcome the electrostatic force of repulsion and keep the protons and neutrons held together. The strong nuclear force is one of the four fundamental forces of the universe alongside electromagnetism, weak interaction and gravity. The strong nuclear force is effective over a very narrow range, about 3 to 4 femtometers. Now, a femtometer is equal to 10 to the minus 15 meters. Not surprisingly, that's about the same as the diameter of a small nucleus. The electrostatic force has an infinite range, albeit decreasing the further away it gets from the source. The electrostatic repulsion has the same effect between two protons as it does between two neutrons, or even a proton and a neutron. The strong nuclear force is an attractive force. Well, it is from about 3 to 4 femtometers down to about 0.5 femtometers. A separation smaller than this is actually a repulsive force, and it acts to prevent the neutrons and protons being pushed together, pushing into each other. So now obviously not all nuclei are stable. Some do break apart, releasing energy, forming new elements. This is what's known as radioactive decay. And you'll recall from GCSE physics that there are naturally occurring radioactive isotopes which release three types of radiation when they decay. These are alpha, beta and gamma radiation. Alpha radiation, denoted by the Greek letter alpha, consists of particles comprising two protons, two neutrons. It's released when an unstable nucleus decays, releasing the four nuclides. It travels a few centimeters in air and it can be stopped by a sheet of paper. It's highly ionizing. Beta radiation is a fast-moving electron emitted when a neutron changes into a proton. It's denoted by the Greek letter beta. It travels faster and further than alpha radiation and can be stopped by a thin sheet of aluminium. Finally, we have gamma radiation, symbol the Greek letter gamma. It's electromagnetic radiation, not a particle. It's emitted by an unstable nucleus. It can pass through thick metal plates. It has no mass, no charge. It's emitted by a nucleus with too much energy following alpha and or beta emission. Gamma radiation is incredibly penetrating, can only be reduced, not stopped really, by a thick block of lead or concrete. Now it's important to remember that nuclear radiation originates from within the nucleus, hence the name. Even the electrons that make up beta emissions are from here, not from the orbitals around the nucleus. Later on, we'll be dealing with beta emissions and what exactly is going on when a neutron is changed into a proton, releasing that beta particle. But that's about it for now. I hope you found this latest instalment worthwhile and informative. If you have any feedback, comments or questions, then please leave them in the comments below. If you haven't already, subscribe to us and don't forget to click on the bell to make sure you get alerts when new content is uploaded. Next time we're going to be looking at photons, the tiny packets of energy that lie behind much of the explanation as to what light actually is and how it behaves. Until then, keep wondering about the universe.